So now we'll look at inverses of matrices. Two by two matrix. The inverse, find the inverse of A is equal to 1, 2, 3, 4. B is equal to -7, 1, 0, 2. Solution. You first find determinant A, which is 4 minus 6, which is equal to -2. And then say A inverse is equal to 1 over determinant A multiplied by adjoint A. So this is a matrix. Determinant is -2. By this adjoint, you switch. So you in the major diagonal, you switch the numbers. So we have 1, 4. So it will be 4, 1 in the major diagonal. In the minor diagonal, you change the signs of the numbers. So we will have -2 and -3 for a 2 by 2 matrix. For B, we'll first find determinant B. That is -7 minus 0, which is -7. Then B inverse is going to be 1 over -7. And then 1, -7. Even if you change the sign of 0, it does not change. You can screenshot. This is enough for 2 by 2 matrices. That's how you get the inverse. Just switch the major diagonal and negate the minor diagonal. So we're done.
Wait, that one.
Next, 3 by 3 matrices. Find the inverse of 1. A is equal to -1, 2, 0, 3, -2, 4. -3, 1, 0. Solution. First thing, you find the first thing you find the determinant of A. So we use the third column. You know, plus minus plus, so plus 0 is just 0, minus 4, and then cancel, cancel, you get 3 minus 6, and then 0 again. So together we have positive 12. So if the determinant is not 0, then you can proceed to getting the cofactor matrix. The cofactor matrix, you now put your signs in order. Then for cofactor matrix, you don't get the entry position. The cofactor of A is going to be a matrix of this form. You go to the first entry, take away its column, take away its row, and then get the determinant of what is remaining. So this cofactor matrix is going to be a matrix of this form. So take away and remain with positive outside, and then negative 2, 4, 1, 0. The determinant of the.
Sorry, sir. I just want to ask. How have we found determinant to be 12? Somehow behind on the values on the rows we cancelled.
We use the third column, which are 2 zeros. The only challenge is that if the mic is there as a problem, we are not so sure if you hear now. You can ask the question, banana. So you're saying that you pick, when you find the determinant of a 3 by 3, you pick any column of your choice or any row of your choice, and you go to each entry, take away the row for that entry and the column, pick the entry position, that number which is there, together with its invisible sign, and then get the determinant of the remaining matrix. Multiply. So if there's a row or column with zeros, that becomes your target because you have nothing to calculate there, only for one number. Like in this case, only for negative 4. Because we had 0, 0, then negative 4, then cut. 3 by 1, 3. Minus negative 3 by negative 2, 6. So I had minus 6. 3 minus 6 is negative 3. Negative 3 by negative 4 is positive 4. Now we're talking about the cofactor matrix. So you get the cofactor matrix. You go for the invisible signs first. This time around, you don't care about the numbers that are on those positions. You just care about the signs. And then you take away. Now you go around all the numbers. Now we'll go to 2. Take away 2 and its row. Then we'll remain with first is the negative and get the determinant. When you take away, you have 3, 4, negative 3, 0. then plus, take away the third one, you remain with 3, -2, -3, 1. So you have found the first row. Second row, minus determinant, take away this guy and this one, you remain with 2, 0, 1, 0. This one is nice. And then plus, take away this guy and this guy, you remain with 3, 4, -3, 0. And then minus, take away this guy and this guy, you remain with 3, -2, and -3, 1. And then plus, take away 3 and this guy, you remain with 2, -2, 0, 4. And then minus, take away this guy and this guy, you remain with -1, 0, 3, 4. And then plus, take away this guy and this guy, you remain with -1, 2, 3, -2. Then now I get those determinants because we know how to get the determinants of the 2 by 2 matrix. That's how life becomes easy now. -2 by 0 minus 4. So we'll get -4. 3 by 0 minus -3 by 4, that is 12 there. Then there's a negative outside. So I have -12. 3 by 1, 3. Minus 6, we get -3. That's the first. So I get determinant here, determinant here, determinant here. Now we're here, determinant here, 2 by 0 minus 0, we get 0. Determinant here, 3 by 0 minus 12, we get positive 12. Determinant here, 3 minus 6, and there's a minus outside, so it becomes positive 3. Determinant here, 8 minus 0, 8. Determinant here, -4 minus 0, -4 multiplied by negative outside, positive 4. Determinant here, 2 minus 6, you get -4. Then you get the adjoint of A. So now we're saying A inverse is equal to 1 over determinant A multiplied by adjoint A. Adjoint A is the transpose of the cofactor matrix. So we have 1 over 12, and then transpose this guy. To get adjoint A, you transpose this. So you have -4, -12, -3. To transpose is to switch. What were rows, they become columns. 0, 12, 3, 8, 4, -4. Any questions? And if you want, this 12 can go inside. If you think it's a good thing.
Sir, sorry. On the middle part here, where you've written the determinant of 3, -3, 4, and 0. Yeah, I'm somehow like behind. How did you come about those?
Determinant of
They are on just the middle number here, where we found 12 there, below -12 on the adjoint, below -12.
This 12
where we found 12 there. Yes, there. So I was asking, how did you cancel the rows and the?
Which entry is that? That is entry on -2. This one. So you cancel here and cancel here and cancel here. Oh. Yeah, right. Cancel wrong, right?
Sir.
Yeah. So it's supposed to be this one, right? The middle. Supposed to be cancel. You get -1, 0, -3, 0. So this is 0. 0. Yeah. So when you do that, it still remains 0. You follow it up here. 0. Now this inverse here, if you are doing the application, if you are doing the application and you're asked to, let's look for a question to do the application now. Don't worry about that, you get the inverse. It will get itself. Hello.
On the adjoint, don't use the adjoint transpose.
We use the the notation here. If there's a wrong notation, then the adjoint is the transpose of a cofactor matrix.
Hello.
Hello.
Sir, I'm confused on the determinant part. That
Of a 2 by 2.
by 3, sir. 2 by 2, it's like now that one. for 3 by 3.
Because it depends on a 2 by 2 matrix. If you know how to get for a 2 by 2, if you know how to get for a 2 by 2, for example, 1, -3, 0, 0. The determinant here will be 1 by 0 minus 0 by 3, which is equal to 0. If you know how to get this determinant, then if you know how to get there's a check somewhere. Somebody says the check. Just let me check. Kindly check on the determinant of 4, 31 plus 5. What was it? 4, 31, -1, 2, -3. Okay. Okay, let me redo so that I can answer some questions as well. So this time around, I'm not putting this structure. We'll just be calculating together. So we get the cofactor matrix of A, which is for the cofactor we put plus, minus, plus, minus, plus, minus, plus, minus, plus. Then we get to the matrix. We cancel here, and get this determinant here. Okay, so -2 by 0, we get 0, minus 1 by 4, we get -4. So we have -4 here. The determinant of A, for those who are talking about the determinant of A, the determinant of A, you pick any row or any column. For determinant's sake, we are picking the third column. The first number there is 0. So you keep 0. So you keep 0 multiplied by, you cancel here, you cancel here. Now, because it is 0, you just leave that canceling, just say 0 and move on. Of course, you know whether it comes out nice or what, it will multiply 0. Plus, now there's a negative sign here. So you pick minus. So you say -4, and then cancel here, cancel here. So you have -1 by 1. We'll get -1. Then 2 by -3. So we have minus 2 by -3. 2 by -3. We'll get -6. Okay, so determinant A is equal to -4 by 5, which is equal to -20. Answer I'm dead.
Sir.
Yeah. So we have gotten, hello?
Answers yale chinja so.
Okay, get it again. We need to get things can change.
Chiwone Njuga Entertainment.
Yeah. So we go to the next one. So the next one is for this side. So you cut here, will remain with 3, 4, -3, 0. Now 3 by 0, 0. 4 by -3, you get -12. Then the minus becomes +12. Then the negative over there, so this is 12. Then you go to 0, cut here, cut there. You remain with 3 by 1, 3, -6. You get it. You get -3. This is -3 here.
Hey, with the kapati kasi.
Then we go to 3, cut here, you remain with 2 by 0, 1 by 0, this is 0. Then cut here, you have -1 by 0, now 0, 0, so this is 0 also. Then cut here, you have -1 by 1, that is -1, plus 6, that's 5. So this is 5. Yeah. Then cut here, you have 2 by 4, 8, and that's 0, 8. 8. Then cut here, -4 minus 0, -4. Then cut here, 2 minus 6. 2 minus 6 is -4. Yeah. Then now, if we write this one properly, the signs will have -4, -12, -3, 0, 0, -5, 8, 4, -4. Then to get the adjoint now, the adjoint of A is the transpose of the cofactor matrix, so that the inverse of A is equal to 1 over determinant A multiplied by adjoint A, which is 1 over -20, -4, the transpose now, -4, -3, 0, 0, -5, and then 8, 4, -4. Has now come out. So no issues.
So,
Hello.
to get the determinant of A, when you cancel a row and the column, and then the remaining numbers that were there are the ones that you use to get the determinant, right?
Yes.
So if you do that to another row and another column, will it give the same thing?
If you do, yes, it will give a same. So that comes on. Okay. Yeah. The problem is that I'm tired. So
Sir.
we need, hello.
Can we just continue tomorrow? Otherwise, I haven't even understood. I just need to watch the video.
I know.
You started the class, sir, I was in a chemistry lecture, so I was listening double. When I do, I did not bet.
So we need to do applications of matrices now and the application of vectors. So I need more in it. So end here today.
Yes, I can end there. We're doing the tutorial and the
Yes.